2.2, I've done it in two parts. The first part we are looking at trig ratios of any angle. So the key part that we're looking here is another trig acronym called Trig. So Trig is just a way of remembering our trig functions. So sine, and you'll see later, sine is equal to y over r, cos is equal to x over r, tangent is equal to y over x. So S, C, and T stand for the same things, but we've exchanged our opposite and hypotenuse for y's and r's and adjacents for x's. So it says, suppose theta is an angle in standard position. Suppose the point at the end of the terminal arm is labeled point px. So here's my angle theta. It's in standard position because it's starting on the x and is starting on the positive x and is making that rotation. So we're going to label a point on that terminal arm as point xy. And the distance that it is from the origin, that point, is r. So it says you can use a reference angle to determine the three trig ratios of the terms of x, y, and r. So if r is the length of my terminal arm, that of course is the side opposite the right angle, so that is my hypotenuse. My initial side is along the x-axis, so that is my x value. And then the side opposite my angle is, the length of that one would be whatever the measurement of y is, so that is my y side. So sine then, if sine is opposite over hypotenuse, then that would be y over r. Cos then is adjacent over hypotenuse, so that's the side beside, so that'll be my x, and my hypotenuse, of course, is r. So tangent then is opposite, so that's y over adjacent, which is x. So that's where our acronym Trig comes in. When you're looking at an angle in standard position and you're trying to find trig ratios, you can use then this acronym Trig, because to find the values of sine or cos or tangent of that angle, you would just use your x, y, and r values. So the trig ratios in the four quadrants. So trig ratios in quadrant 2, they're between 90 and 180 degrees. So that could be any angle. So we'll draw our angle, our terminal arm there. So this would be my angle theta. So this side here is using the reference angle to calculate it. So my terminal arm would, or my length of x and my height of y would be found by dropping down that perpendicular line. So if I think of values, my r is my hypotenuse, and it is always positive. You're always going to have a positive value there. My y, because it is above the x-axis, is positive. But my x, because it's on the negative side of that arm, is going to be a negative x. So x is negative, y is positive, and r is positive. So if you do your trig ratios for theta, if it's between 90 and 180, so if it's in quadrant 2, your sine of theta, so sine, that's that sur, so that's y over r, and y and r are both positive. So that means that your answer, your sine of theta, will be greater than 0 because it's positive. Cosine of theta then is adjacent over hypotenuse, so that's the negative x over r. So that means it's going to have a negative value. So cos of theta will be less than 0. So it's going to be negative. And then tangent So that's the tix. That's the y over x. In this case, it's going to be y over negative x. So that means that tangent of theta in quadrant 2 is going to be a negative or less than 0. So in quadrant 1, if it's between 0 and 90, so again, this is your x, this is your y, that's your terminal arm, this is angle theta. I drop down a perpendicular side. Taking a look at this, I know that this is x. I know this side is y because it's measuring the length of y. This is r. So then my trig functions for this, my sine of theta is going to be y over r. Everything is positive. Cos of theta is my x over r. And those are both positive. And tangent of theta then is opposite over adjacent, so that's y over x. So that means in quadrant 1, sine is going to be a positive value or greater than 0. Cos is going to be a positive, and tangent is going to be positive. So quadrant 3 then. That's between 180 and 270 degrees. So quadrant 3 means my angle will be somewhere in here. So my whole angle is going to go from here to here. That's my theta. Since I'm in quadrant 3, that means I'm going to be using my reference angle to calculate these values. So I know by looking at this is y and this is x. This again, my x side here is in negatives. My y side is down, so that's also negative. My r is the hypotenuse, so it's always positive. So for this one, sine of theta is x over r, but x is negative. So that means sine of theta is less than 0 or negative. Cos of theta, so that's the, that should be y. Negative y over r. Cos is the Kixer, so that's x over r. X is negative, r is positive, so that means cos of theta is less than 0. And then tangent theta, that's my tix, so that's y over x. So I have negative y over negative x, which makes that positive. I'm hoping this isn't crackling too bad for you because it keeps making some bad noises right now. So tangent is positive. So finally we have quadrant 4. Quadrant 4 is between 270 and 360 degrees. So if this is my terminal arm, my theta is going all the way around to there, but my reference angle is what I'm going to be looking at. Whoops, pretend that's perpendicular. So on this one, my x is positive, my y is negative, and my r, or my hypotenuse, is positive as well. So sine then, sine is opposite over hypotenuse, so negative y over r. So that means sine of theta will be negative or less than 0. Cos of theta is adjacent over hypotenuse, so that's my x over r. So cos then is greater than 0. And tangent of theta, that's my y over x, so that's negative y over x. So that means tangent of theta is less than 0 in quadrant 4. So you could go through those steps every time when you're doing a calculation, but there is a quicker way. and that's called our cast rule. So it says, here's a way to remember the sign of the trig ratios in each quadrant. So without having to draw it out every time, if you remember the cast rule, then that is going to help you to remember where is a value, a theta value, going to be positive and where is it going to be negative in which quadrants. So for the cast rule, we start this way. We start in quadrant 4 is our C, quadrant 1 is our A, quadrant 2 is our S, and quadrant 3 is our T. So what that stands for is, in quadrant 4 where the C is, only the cos ratio is positive. So if I just look back at the two examples that are on this page, in quadrant 4, just going to slide this down, in quadrant 4, cos was positive, tangent was negative, and sine was negative. So the A stands for all. So all three trig ratios are positive in quadrant 1. So if you flip to the first page, sine's positive, cos is positive, tangent is positive in quadrant 1. So the S then stands for sine. So in quadrant 2, only the sine ratio is positive. Oh, wrong way. So if I look here, sine is positive, cos is negative, tangent is negative in quadrant 2. And then finally the T obviously will stand for tangent. So in quadrant 3, only the tangent ratio is positive. So if I look up here, a little further, sine is negative, cos is negative, tangent is positive. So that means if I asked you to find the tangent of 112 degrees is in quadrant 2, but only sine is negative, so I know I have to, or sine is positive, so that I know that my answer needs to be a negative value. So that's what you use the cast rule for. Okay, so doing an example, so we're going to do all of the solving for this one. Whenever you're given an example or a question like this, you need to make sure you draw it out. Get your Cartesian coordinate plane on there, label it, and then put your information on. So, I have a point, -5, -12. So remember, this is my x and this is my y coordinate. So -5 and -12 means that I'm going to have both values negative. So x is negative on this arm, y is negative on this arm, so -5, -12. Let's say that's my -5, and this is going to be approximate. This is my -12. So my point is going to be about right there. So you plot your point, and then you draw in your angle. So I'm going to put this to there. So that means that is like my terminal arm. So it's like saying my angle theta is going from here to there. So to finish this off, I need to make it into a right triangle. So that means I'm going to drop down the side perpendicular to that x right there. So if my x was -5, then that means that is the measurement of this side here. So this value here is -5. My y coordinate was -12, so that means that this side here is -12. I need to find r. So again, just like what we were doing in the other section, do an inventory of what you know. So I do know that my x is equal to -5, my y is equal to -12, I don't have r. I'm looking at a right triangle, so that means that I'm trying to find the sides. I'm going to use Pythagorean theorem. So instead of using a squared plus b squared equals c squared, we're going to use x squared plus y squared equals r squared. So negative 5 squared plus negative 12 squared equals r squared. So this is 25 plus 144 is equal to r squared. So 169 is equal to r squared. Square root 13 is equal to r. And again, because this is the hypotenuse, it's not positive negative 13, it's just 13. If I was finding x or y, then it could be a positive or a negative. What I would have to do then is look at which quadrant am I talking about. So if I was already told that my r was 13 and my y was a negative 12, then I know the value I'm looking for x when I solve would be a negative 5 because it's in quadrant 3. Okay, so now I have my ratio, or my sides. I can find the exact trig ratios for sine, cos, and tangent. Excuse me. Sorry, I just had a little coughing fit there. Okay, so now I've got my 3 values I can find, sine, cos, and tangent. So sine of theta, sine is equal to y over r. So my y was negative 12 and my r was 13. I can't reduce it or do anything else, so I leave it like that. Cos is my Kixer, so x over r, so that's negative 5 over 13. Tangent to theta is my Tix, so that's y over x, so that equals negative 5 over negative 12, which is 5 over 12. Did I say, oh, I wrote that down wrong. It should be negative 12 over 5, sorry. So 12 over 5. So I can check this with the cast rule. I've got sine and cos are negative, tangent is positive, so I'm in quadrant 3. So using the cast rule, only tangent is positive in quadrant 3, right? I've got C, A, S, T. So only my tangent is positive, so I know I am correct. Next example says, determine the exact values of cos of 135 degrees and sine of 245 degrees. So as soon as you see exact value in there, chances are you're going to be using the 30, 60, 90 or that 45, 45, 90 triangle. So what I do first of all is I draw this in here. So 135 degrees is approximately like that. So it's in, this is theta. I'm in quadrant 2. So in quadrant 2, if I want to find my reference angle, it's going to be 180 degrees minus theta, so 180 degrees minus 135. So that's 45 degrees. So since it's 45 degrees, then I know that I'm going to be using my 45, 45, 90 triangle. So since my reference angle, and I'll write that in purple here, is 45 degrees, that means if I finish this off so that it is a 45, 45, 90 triangle, now according to my special triangle, my legs are 1 and my hypotenuse is square root 2. So I know then cos of 135 degrees is going to be the same as my reference angle cos of 45 degrees. Cos of 45 degrees, so cos is adjacent over hypotenuse. So that's 1 over square root 2. But this is in quadrant 2. In quadrant 2, according to cast rules, only sine is positive. So that means that cos of 135 degrees is going to equal negative 1 over square root 2, which if I turn that into a proper radical, so rationalize it, it's going to be negative square root 2 over 2. So that is my final answer. So cos of 135 degrees is equal to negative square root 2 over 2. B asks us to find sine of 240 degrees. So 240 degrees, I've got 90, 182, so 240 is going to be in this quadrant. So that's theta. My reference angle then is going to go from, oh, why didn't that turn purple? From here to here. So because it's in the third quadrant, that means I'm going to take my 240 degrees minus my 180 degrees to get my reference angle. So my reference angle is 60. So if it's 60 degrees, that means I'm using 30, 60, 90 degree triangle. So for a 30, 60, 90 degree triangle, I'm just going to finish this in, I guess, in red. So this is a right angle. If this is 60 degrees, that's 90. That means that this side is 30. So 30, 60, 90 degree, my sides are 1, 2, and square root 3. So the side opposite the shortest side has a value of 1. The side opposite the hypotenuse has the largest value, which is 2. And then the 60 is the middle value, so it gets the middle square root 3. So if I look at this, my side that has a value of 1 is on the negative x-axis, so that should be a negative. The side that has the value of square root 3 is in the negative y, so that's going to be negative as well. So that means my sine of 240 degrees is going to be the same as the reference angle, which is sine of 60 degrees. Sine is equal to opposite over hypotenuse, so that would be negative square root 3 over 2. So if I check this using my cast rule, I've got CAST, only tangent can be positive in that quadrant, so it needs to be negative, and that's the way it worked out. So if you forget to change these signs here when you've put those in their proper spots, if you just put them with all positive ratios, then you just use that cast rule to check and see if you're correct. So the next example says, suppose theta is an angle in standard position with the terminal arm in quadrant 3 and tangent theta is equal to 1/5. Determine the exact value of sine and cos. So the first thing I do is I know, okay, I'm in quadrant 3, so that means that this is going to end up somewhere over here. My terminal arm will end up somewhere in quadrant 3. I have tangent of theta is equal to 1 over 5. So if tangent theta is equal to 1 over 5, and I know that tangent is equal to y over x, because that's the ticks, then that means what I do know is that y is equal to 1 and x is equal to 5. Now I'm in quadrant 3. So because I'm in quadrant 3, that means that in quadrant 3, my x is negative and my y is negative. So if I take a look on here, if I plot that down that way, my x was equal to negative or was equal to 1. So that means that this value, even though it's not exact, this would have to be a negative 1 because it's in the negative side of the y values. My x is going across the negative x-axis, so this has to be a negative 5. So that makes a difference when I'm doing my calculations. So negative 1 divided by negative 5 is still positive, so that works for my cast rule because tangent would still be positive there. So now what I can do is I can find r and find the values of my sine and cos. So r is equal to x squared plus y squared. So r squared is equal to negative 5 squared plus negative 1 squared. So that's 25 plus 1. So r squared is equal to 26 square root. R is equal to square root 26. Now this said to find exact values. Because I wasn't given an angle, or I wasn't given, my ratio wasn't a one using one of the special triangle values. So for 45, 45, I would have tangent theta is equal to 1, or it could be 2, as long if any whole number, because then you're just multiplying your unit by whatever number. And I know it's not 30, 60, 90 because I'm not using any of those ratios with square root 3 and 1. So I leave it at r is equal to square root 26. I can't reduce that any further, so it's just left like that. So that means to find my sine of theta, so this is my reference angle theta is there, so sine of theta. So sine is equal to y over x, not y over x, y over r, because it's sur. So y is negative 1, r was square root 26, so if I rationalize this, this would be negative square root 26 over 26. Cos of theta then, that's the sur Kicksur, so that's x over r, so that's negative 5 over square root of 26. So if I rationalize that, that's going to be negative 5 square root 26 over 26. So that now is done. Quadrantal angles then is an angle in standard position whose terminal arm lies on one of the axes. And this is supposed to be a table here, but it didn't really do very well. So this is my x and my y. If you think about this as being on a unit, so if I plot this point here and I'm using a unit when you're talking unit circle, unit triangle, your side lengths are always equal to 1. So if this is equal to 1, this would be at the point 1, 0. This point here would be at 0, 1, because if I'm thinking of coordinates, this point here would be at negative 1, 0, and this point here would be at 0 and negative 1. So if I think of the value here at 0, and 0 and 360 would be exactly the same, because whether I'm starting here or I'm going all the way around, I'm ending up on this positive terminal arm. So for 90 degrees, whoops, well, yeah, I'll do this one. So for 0 degrees, or 360 degrees, my x equals 1, my y is equal to 1, so that means, 0. My r is going to equal to x squared plus y squared. So 1 squared plus 0 squared is just 1, so it's a 1. So for 90 degrees up here, x is equal to 0, y is equal to 1, so then r is going to equal 0 squared plus 1 squared, which is just in the square root of that, so that's just 1. For 270 degrees, My x is equal to -1. My y is equal to 0. R is equal to the square root of those two values squared and added together. So -1 squared is 1, plus 0 is 0. Square root of that is just 1. And then down here at 270 degrees, I have x is equal to 0, y is equal to -1, r then, of course, is equal to 1. So your r is always equal to 1 on a unit value. Okay, so we're going to put in some lines here if it'll let us. Okay. So sine then. Sine of theta is equal to y over r, cos is equal to x over r, and tangent is equal to y over x. So at 0 degrees, if I do y over r, I've got 1 over 1, so that's 1. Cos is equal to x over r, so that's 0 divided by 1. Oh, sorry, I'm looking at 90 degrees. Let me do that again. So for 0 degrees, y is equal to 0, r is equal to 1, so that's just 0. For cos is equal to x over r, so that's just a 1 over 1, so it equals 1. Tangent of 0 degrees, that's y over x, so that's 0 over 1, so that equals 0 as well. For 90 degrees then, y over r is just 1 over 1, so that equals 1. Cos of 90 degrees is x over r, so that's 0 divided by 1, so that's 1. And then tangent is equal to y over x, so that's 1 over 0, which is undefined. So you can't find that one because you can't divide by 0. This said 270, they should say 180, sorry. For 180 degrees, so that's this point right here. 180 degrees, y over r is 0 divided by 1, so that's just 0. X over r is -1 divided by 1, so that equals -1. And then tangent is y over x, so that's 0 divided by -1, so that just equals 0. So 270 degrees then, that's for this point down here. Y over r, so that's -1 divided by 1, so that's just -1. Cos of 270, x over r, so 0 divided by 1 is 0, and then tangent is my y divided by my x, so -1 divided by 0, so that too is undefined. So when you're asked to find the values of quadrantal angles, your trig values of them, you can either memorize this chart or just remember what are the coordinates you're looking at. Your 0, 1, 1, 0, -1, 0, and 0, -1. So you've got those 4 that you're looking at, and that's what you use then as your x, y. And of course your r for each one of those is equal to 1. So then you can calculate your exact trig value for it.